Right, putting that into the objective function, right, we're going to substitute this into objective function, which will render its single variable. All right. So we have, right now we have v, and it's really a double variable, or a two variable function, and that will be x squared y. Right? It's a two variable function, two independent variables, one dependent variable, but we're going to render this thing single variable. All right, we're going to substitute in something for y, and that's this expression here. So we'll have x squared, and in place of y, we'll have 300 minus x squared over 2x. All right, so now we want to simplify this as much as possible, but you do see it's now all just a function of x. And this is good because now we can apply our regular derivative process to it, which has been single variable throughout the entire course. So we'll cancel this x here with one of these out here, and we'll end up with, I'm going to pull this 2 out as well to the outside. It'll be like this, 1/2, right? 1/2 on the outside, x times 300 minus x squared. Now I'm going to rewrite this. I'm going to go ahead and multiply x into here. I know I'm going to take a derivative in a second, and this is really just a little polynomial, so rather than do what would be a product rule here, a little unnecessary in this context, I'm going to rewrite this as 1/2 300x minus x cubed. All right. That's not the only way to write that, but it's a very reasonable way. So now we'll do what we said in the beginning. We would like to take the derivative of this volume, set equal to 0, and see if we can find any relative extrema using the first derivative test. Pretty easy derivative. Like I said, the setup is the crucial part of these types of problems. So dv dx, or v prime, should be 1/2 is left alone. The derivative of 300x minus x cubed should be pretty obvious by now, 300 minus 3x squared. Set equal to 0 and solve. All right, let's see what we get. Well, 1/2 has no bearing on this really, on this equation. So we have 300 minus 3x squared. We can even factor a 3 out of there, and we'll get 100 minus x squared equals 0. The 3 has no bearing on this equation. It looks like we have 100 minus x squared equals 0. So therefore 100 is x squared, which implies that x is plus or minus 10. Right? Just take the square root of both sides. Now we're dealing with physical objects here, so there's no negative lengths or widths or anything like that. So we immediately discard the negative 10. That's not necessary. And keep only the x equals 10. All right, now I want to know if this is actually a maximum, minimum, or nothing. It could be nothing at all. Maybe there's no maximum in this problem. Not every problem has a maximal solution or a minimal one. Can't optimize everything. So let's go ahead and make a sign chart like we've done before. Now we really had negative 10 and 10 on here. Okay, so this is my sign chart for x. So let's think about this for a very brief moment. If I was including the whole real line, if x could theoretically be any number it wanted, then I would put both of these on this sign chart. I put negative 10 and 10 on here. But we already know that since x is a physical measurement, we're not going to have any negative values. So the lowest x could possibly go is 0. Okay, so we've got a truncated sign chart in a sense due to the nature of the problem. Okay? So the only number I need to put on here is the 10. It doesn't really matter where, 10. All right, so let's go back and see now what happens. If I take a test case between 0 and 10, like 1 or something. So I plug 1 back into the derivative. So we have 300 minus 3. Well, that's positive, obviously, right? Times the 1/2 positive out here is still positive. The derivative is positive when I test 1. So I'm going to write v prime here. V prime is positive on this interval. Once I pass 10, just go to 11 or something. It's not hard to see, even back here, right? 300 minus 3 times 11 squared, or you can just remove the 3 and do it this way, doesn't matter. Either way, you'd have 11 squared is like 121, right? So 300 minus 3 times 121 is obviously now negative, or you can look at it here, 100 minus 121 is obviously negative, times the 3 times the 1/2, still negative. Okay? It's negative. So whatever you test over here on the right, I'm just picking 11, will be negative, right, for the first derivative. So therefore, 10 is certainly a local maximum. Okay. So x equals 10, up a little bit. X equals 10 is the location of a relative maximum.